Hi everybody, consider a polynomial px equals to x cube minus 3x plus 1, and then we have polynomial qx which is equals to x cube plus ax square plus bx plus c. Now let polynomial qx have integral coefficients such that the fifth power of the roots of polynomial px are the roots of polynomial qx. Then find the value for a, b and c. So first you please give your try to this question and keep watching for the solution. Now we are using Vetta's formula. This is used for the relation in the roots of cubic polynomial and their coefficients. So consider our general cubic polynomial px which is equals to ax cube plus bx square plus cx plus d. Let alpha, beta and gamma are the roots of polynomial above, then the sum of their roots alpha plus beta plus gamma is equals to negative b divided by a, and alpha beta plus beta gamma plus gamma alpha is equals to c by a, and multiplications of roots is equals to negative d divided by a. And we use these formulas for finding our answer. Now consider our polynomial px. Now let alpha, beta and gamma be the roots of polynomial px. And we have polynomial qx which is equals to x cube plus ax square plus bx plus c. Then alpha to the power 5, beta to the power 5 and gamma to the power 5 are the roots of polynomial qx according to our question. Now using Vetta's formula in polynomial qx, then sum of the roots is equals to negative a divided by 1. So this is equals to negative a, and the multiplication of adjacent roots and their addition is equals to b divided by 1, which is equals to b, and the multiplication of their roots is equals to negative c. So once if we find the sum of roots, then we can easily find the value of a, and then similarly for b and c. Now the identity which we are using is x cube plus y cube plus z cube minus 3xyz is equals to x plus y plus z times x square plus y square plus z square minus xy minus yz minus zx. And actually we are using our result from this theorem. So if x plus y plus z is equals to 0, then x cube plus y cube then plus z cube is equals to 3xyz. And we can easily got this result from our identity above. So if we put x plus y plus z is equals to 0, then our RHS hat corresponds to 0, and then simply we have our result that we are in need to prove. Now we have polynomial px, and alpha, beta and gamma are the roots of polynomial px. Then the sum of roots is equals to 0, and then the multiplication of roots is equals to negative 1, and the sum of adjacent multiplication of roots is equals to negative 3. Now from this result, alpha plus beta plus gamma is equals to 0, we can say alpha cube plus gamma cube plus beta cube is equals to 3 alpha, beta and gamma by our identity. Now if we look at alpha, beta and gamma, this is equals to negative 1, and this thing is b alpha, beta and gamma, so our this thing is equals to negative 3. Now squaring both sides of alpha plus beta plus gamma square, then we have this. Now putting all the values, so finally we have alpha square plus beta square plus gamma square is equals to 6. And now we have find two more things. Now for alpha to the power 5 plus beta to the power 5 plus gamma to the power 5, we are just multiplying alpha square plus beta square plus gamma square times alpha cube plus beta cube plus gamma cube. Now opening the parenthesis and multiplying all the terms, and then we take alpha 5 plus beta 5 plus gamma 5 at one side and making some pairs like that. So finally we have this, and we know that alpha plus beta plus gamma is equals to 0, So we are substituting these values with only one value using our this result. So finally we have this. Now reopening the parenthesis and taking alpha plus beta plus gamma as common, so we have this. Now we have converted this thing into this thing, so we can equate these both, and now putting the values by our given information, so we have this. So finally we have alpha to the power 5 plus beta to the power 5 plus gamma to the power 5 is equals to negative 15. Now for alpha beta to the power 5, beta gamma to the power 5, gamma alpha to the power 5, we just do the same thing that we do before. Now we multiply the second power of the sum of roots and then multiply this with the third power of the sum of the roots. So now opening the parenthesis, so we have this, and now opening completely the parenthesis, so we have this. Now we take these terms common at one side, so we have this. Now take alpha square, beta square plus gamma square common from the rest of the term, then we have this. Now make the pairs of that and take common things from them, so finally we have this. Now we know that 6 is equals to alpha square plus beta square plus gamma square, so we can replace the rest of the things with the alternative values, so finally we have this. Now reopening the parenthesis, so we have this. Now take these terms as common, so we have this. Now we have converted this thing into this thing, and remember this identity, we will use this later. So once if we find the value of this and this, then we can easily find the value of the result which we are looking for. Now squaring both sides of alpha beta plus beta gamma plus gamma alpha, so we have this. Now we have this all information given, so now putting the values, so finally we have alpha beta square plus beta gamma square plus gamma alpha whole square is equals to 9, and this is also an important result. Now we do the same thing for alpha beta whole cube plus beta gamma whole cube plus gamma alpha whole cube. For this we just multiply alpha beta plus beta gamma plus gamma alpha with alpha beta whole square plus beta gamma whole square plus gamma alpha whole square. Now opening the parenthesis, and now completely opening the parenthesis and take these things commons on one side, and from the rest we take alpha beta and gamma as common and making the pairs of that and take common things, so finally we have this. And we know that alpha plus beta plus gamma is equals to 0, so substituting the values with only one value, so we have this. So finally we have this, so we have converted this thing into this thing, so we can equate these both. So now we have this all given information, so now we can easily put all the values. So finally we have alpha beta whole cube plus beta gamma whole cube plus gamma alpha whole cube is equals to negative 24, and this thing is also important. Now we have this all given information, and we have our this equation to find the value of this. Now we put all the values, so finally we have alpha beta to the power 5 plus beta gamma to the power 5 plus gamma alpha to the power 5 is equals to negative 198, and this is a very important result. So we back to our first page. So we have already found the value of alpha to the power 5 plus beta to the power 5 plus gamma to the power 5, which is equals to negative 15, and all other values that are in need to find our answer. Now we put all the values, so we have a is equals to 15, b is equals to negative 198, and c is equals to 1, and that is our correct answer. Now it's the time for the rating of the problem. So for creativity, I gave this problem 4 points out of 10, and for mathematical thinking, I give this problem 4 points out of 10, and for focus needed, I want to give this problem 8 points out of 10. So the average hardness of this problem is 5.3 bar.